Okay, we are back here. I got the Trav A Dial adjusted and tracking correctly. Now this was the hot item before digital readouts, and older people like me have gotten used to these and prefer them over digital readouts to this day, and I think I can work faster with this on less complicated parts, I suppose. Okay, so this here is graduated in thousandths. You can set the bevel here. You can set the this to 5, the full travel is 6 inches, and you can set this to 0 at any point here, this little dial. Okay, so you got control to 1/1000th of an inch, and these are really quite accurate, and they were quite expensive in the day. Probably quit making them almost 20 years ago. Okay, so we got control down to 1/1000th here for longitudinal travel. Now, this is an old-time thing here I'm going to talk about. And these here are called end measuring rods, and these haven't been used for decades. You know, people still use them. I use them. You can position things quite accurately with these rods and these super high quality micrometers with 10,000ths verniers. But to make these a lot more sensitive, you stack these along a line, and then you put an indicator on the end. Hey, Chloe, come on in and say hi. Come on, sweetie. Maybe we can lure it in here. Okay. So you can set these up and have a stop on your machine travel and bring this to 0, have the micrometers in line, and you can easily set things up to 10,000ths of an inch. You know, it's just a very old-time way to do it. They even set jig bores up. I'm going to set up this old Brown and Sharp milling machine to accept this, so I can do some high accuracy positioning on that very old machine. And then also I can use these on the radial drill press. And I'm thinking of getting a CNC type subplate to put on the top of that table there. And I can do all kinds of things with that. And position parts on an accurate plate using these things, you know, moving the part rather than moving a table in that. But anyway, we'll get back to the lathe here. Now, the same principle is right here built into the Monarch 10EE. We've got a stop rod here, and it's graduated. Well, it's an inch metric lathe here, so this one's graduated on millimeters on one side and inches on the other to 6 inches, okay? So, and you know, like I say, this is accurately made, and it's got 1/2-inch stops, see? So we can go, let me knock that to 5.5, then you push it in, you hear it click. Okay, then we go over here, and we've got that 1/2-inch travel. It's a little bit sticky. Let me stick this out a little bit more. We'll go in the millimeters. Okay, so you snap that thing in. And then you got this 1/2-inch travel. Let me get that on there tight. I haven't used it for a while, but it's kind of sticky. I'll have to squeeze it out. So this inside micrometer stuck on the rod will adjust in those 1/2-inch increments there. Okay, so you stick this out here, use a 10,000ths indicator, and with this micrometer here, the 10 thousandths indicator, and even using gauge blocks if you have to, you can set the longitudinal to 1/10,000th of an inch actually pretty quickly. Okay. Then the factory had quite a few different things here. And I have this clamshell thing that fits on the older lathe, but it doesn't fit on here. But this works real good because I can just snap this off, you know, and put it on when I need it, which isn't all the time. Usually thousandths of an inch is good enough. Okay, instead of the DRO, of course, for the longitudinal feed, I mean the cross feed now, we've got the regular, rather large micrometer dials here, and I can easily, on diameters and stuff, plus or minus 1/2 thousandths of an inch. Of course, this is an extremely accurate machine. And you know, these big micrometer dials on here, kind of almost like on a optical comparator. You know, it's like a precision instrument. So, okay, I got control to plus or minus 1/2 thousandths, so to 1/1000th graduations here. Then I go back here, and this is something I cooked up. Now, the factory had a cool little thing that mounted on the side here with turrets and those micrometers and a 10th indicator, and Hard Inch had the same thing, but I don't know what Hard Inch did longitudinally for 1/10,000th of an inch, but I'm sure a lot of people know. Okay, so we got a 10,000ths reading indicator here, and so I use that for that two-step finishing cut process that is outlined in that kind of metal literature I'm always talking about. Okay, so I have that reference. I'm just not making stuff up. Okay. And with that Kennametal system on a jig bore precision machine, they say an average operator can get plus or minus 80 millionths of an inch, okay, using their inserts and stuff like that. But a good lathe driver should be able to get at least plus or minus 1/10,000th of an inch on a diameter, on a, you know, on a shorter diameter. Some of these lathes here are spec'd out, capable of doing 3/10,000ths consistently on a 12-inch length. And people go, oh, my lathe will hit that. Well, you know, are you really sure? You know, are you really that sure? But tweaking around a lot of times, and that's where the experience comes in. That's what sets this lathe apart from the old one I showed you outside, is that it will turn that way, you know. And that's why I preserve this machine, because if you use it over here, then it's not going to keep turning that length. See, I really take care of this one. I always park the carriage at this end, and you'll find some interesting things if you park the carriage at that end. Because you keep doing that, and you'll find it'll be tighter at this end. You know, think about that. Okay, I might get into that, some of those extreme details, but I was always advised to park the carriage at that end. If you look over here, you see the axle sense near that end. I just have it. You get the carriage back away from the chuck, and you start up the machine, and you oil up the carriage. You oil everything up before you move it, right? Because you have grinders. Have grinders. If you have a bench grinder anywhere in here, and you grind something with it, that dust is going to get clear around everywhere in the shop. So before you move anything, you wipe everything down every time. I do. And look at the shape this machine's in. How about that? It didn't happen by accident. Chloe, come on in here and say hi. I don't know. You know, Chloe, there's the actors strike going on. I don't know. So that is how you can control to 10,000ths of an inch discrimination, or even better. You know, you can. I've got some of those mirror parking meter things that I think one of them reads 2/10, but I just haven't really found I needed that. So I can hit pretty close stuff on here. You're gonna get in trouble, Chloe. That kind of bugs people, you know, kind of a constant. Chloe, knock it off. Okay. I'll think of something and be back. Hey, okay, you know, there's no perfect lathe. And some lathes have some kind of funny things about them, and I get a kick out of people's reactions over stuff. One guy completely flipped out on one of these machines. He goes, there's no ball oiler here. I go, you know, my cheap Arbor Freight lathe's got a ball oiler. Well, I don't know what to say. They forgot to do it. What do you do? So, hey, Chloe, I'm telling you, she's gonna get me in trouble. Come on, sweetie. See if I can lure her in here. So anyway, let's lubricate this thing. Now these things float. You can lock them, and you force the gears to turn, but you can let them float. Like that's really easy to turn. This has got the inch metric, and there's gears in there. Okay, so this doesn't oil itself like the axles, and you wouldn't believe the axle oils the top slide. I'm gonna go get Chloe. Okay, so you take these two screws out. I backed this all the way up, right? So you take these two loose. Oh, she's gonna get. Guy next door, I think, watches Murder, She Wrote or something, and doesn't like the Chloe doing that. So I got a hold of it, and I'm gonna screw it out. Ah, look at that. Isn't that pretty? So it doesn't oil itself. So I'm going to oil. There's a thrust bearings here. See that? Let's get that oil going out there. This is way oil like Vectra number 2 or something. And I'm going to oil that screw real good. I'll set this down here real quick. I got this backed off. And I'm going to take a wipe the little ways here. Get some oil up front here on those ways, like Bill does, lots of oil. Okay, then you can take and move this back and forth. Push it forward. Okay. See, I'm going to do some threading for you. There we go, lots of oil. Bill liked lots of oil too. Okay. That's how this is doing here. Looking good, isn't it? So, you know, the end plays good, you know, that's okay. Lots of oil. That's an expensive screw. Lots of oil. Okay, we want to take good care of our screws. So we're going to get this back all the way and try to stab that in, and it's stabbing in. Yeah, you see, you got to oil this. You know, I got oil in there, and it doesn't take long to get this back together. It's easy. You don't have to cry. Put oil in. I think you really do need to take this off and get the oil into that dial, because that's complicated in there. Okay. So I got the screws back in. And there's one more thing I'm going to show you. Let's see how it feels. Ooh. Yeah, that's nice and smooth. I can even feel the gears in there. Got some oil. Yeah. I'll get that back there. See, if you loosen that, then that dial skates and it's easier to crank. I got about the right tension on there for threading. I like that. So we're looking good there. I'll have to run it back a couple times to straighten the gearbox because I moved it quite a bit. Well, that camera shut down again, but I don't think it was at too bad of a time. I got the top slide back together here. A fellow was over here and noticed that. He goes, oh, that's different than mine. Well, what I've done is I've taken a quad ring, which is sort of a square O-ring, and I stretched it over the base, see? And it keeps that grit out. See that? Isn't that nice? So you can keep the grit out by stretching an O-ring. I think a quad ring works better. They're kind of square. You can get them at, I guess, Granger's or something. Well, it said I had a 75% battery. Then it went off and said the battery was too low. So maybe that battery is weak. I'm marking the batteries, trying to find the bad ones. Okay. So we lubricated the top slide, and we'll go down to the cross slide screw. Now the cross slide is automatically lubricated by the oil pump that's down here, activated by the feed rod and cams from moving the carriage boat. Okay, so there's no automatic lubrication to the cross feed screw. So what I have done is I've taken, this is the binder bolt when you're using the taper attachment. Here's the taper attachment here. Look at that. Ball bearing taper attachment with micrometer adjustment. Little window over there. I cracked it like everybody tries to do to clean it. I'll have to get another one of those. Okay. I think it's just a little cover glass or something. So this is the taper attachment binder bolt. And it goes down. I'm going to take it all the way out. I know I can stab it back in. It goes all the way down. Well, I can't really see down there, but it goes all the way down there. And there's kind of like a brass cage around that cross feed screw. And here's the nut for it. So I've taken this bolt and I drilled a hole through it. Let me get the top off that. I do it with my thumb. Here, I'll set the camera like that and you can watch me. And I made a little brass cap. If I can get it out of there, it's kind of hard. Well, it's not going to cooperate. Yeah, it is. See, I made that little brass cap and I sunk a 1/4 inch. I am having crazy camera shut-off problems again. I don't know. But anyway, I drilled this bolt here that locks the cross feed to the screw. It locks the screw down when you're using the taper attachment. And I drilled a hole through it. I'll put it back in, and it goes directly down to the cross feed screw. And I drilled a hole in the top, and I can take an oil can here, see, and oil it, and then move the cross slide and oil the cross feed screw. Then when I'm done, I put the little cap in it I made. So I drilled that, ran an end mill down into it, made a little cap, and I can oil the cross feed screw with that thing. I hope I didn't block that thing totally. I think you could see that. So everything's oiled up, and I'm going to start showing thread cutting using the electric lead screw reverse, not using the electric lead screw reverse, and going in and out of metric and inch threading modes. That's going to be pretty cool. So that's coming up, and we're all lubricated up and we're all adjusted. All the oil levels are up, and we'll get on that in the next videos. Have a good day.